Okay, so concentration is this kind where you have mole per dm cube or gram per dm cube. So they have in two kinds of units also. You will depend on amount of solid that you have and then also the volume of solvent. So solvent is in dm cube, then the solid will be either in mass or in mole or in grams. Magic formula. So my students tell me that they remember it this way. Concentration in mole per dm cube, right? So that means they put number of moles divide by volume. Then if it's gram per dm cube, right, they use the mass over volume. Mass of the substance over volume. Yeah. Then if you cannot remember the formula, then use proportion. Proportion means, according to this, right, that means it's in 1 dm cube, how many moles are there? Then this one is in 1 dm cube, how many grams are there?
Okay.
Yeah. In my case, right, my memory isn't that great. So I seldom remember the formula, so I will just use proportion.
Oh.
Yeah, if you see me talking in proportion, you know why. Then if you want to convert from mole per dm cube to gram per dm cube, mole to gram times mr.
No, I was wondering why can times and then become gram.
You see the arrow sign. So if it's mole to gram per dm cube, right, you times mr. But if it's gram per dm cube to mole, you divide by mr.
Okay, so this one is
calculate the volume of water needed to dissolve 2.5 grams of sodium chloride to make a concentration of 5. So you know concentration is equals to what? Mass over volume.
Yeah.
So it's 5 equals to 2.5 divided by volume.
12.5.
Volume equals to 2.5 divided by 5.
Oh yeah.
So this is how you use the formula lah.
Okay.
Then same goes.
So it's concentration.
You look at the unit.
Oh, so I need to make this into 1,000.
No, you have to change that to dm cube. So you divide by 1,000.
Oh, yeah.
Right.
No, it's more. Oh no, it doesn't matter. Right? I can change it with the MR thing.
Yeah, depends on what you want to do it.
To change it is divide MR. MR. This number is going to be so small. The number very big.
You want to check the formula again?
Is it?
Gram per dm cube to mole per dm cube is divide by mr.
Oh, not the other way. Okay.
Okay, Then you see everything come together.
Balanced chemical equation.
Yeah, then everything come together.
Excess zinc powder. What they mean by excess?
Means zinc is in excess and then sulfuric acid is limiting.
Oh.
So nice of them, they tell you that.
It's not very helpful.
You don't know what you have in part B and part C, right?
That's true. Zinc and sulfuric acid.
Cannot help you already. This one you should know already. By the third session, you should be okay with this.
Acid is with hydrogen, right? So it's hydrogen and sulfur.
Hydrogen and sulfate.
Sulfates. Oh.
还没有 memorize 哦。
Yeah.
You have to memorize it quickly soon, because if not, right, you will be always bogged down by what is the formula?
Okay, zinc is 2 also. It's balanced already.
Zinc sulfate. Yeah, looks like it.
Okay. Oh, I didn't write states on this.
They never ask for it.
That's true. Okay.
Okay, don't delete. Don't delete.
Okay. In hydrogen gas producing reaction. Oh, so I find this one.
So you can find the number of moles of sulfuric acid.
Oh, I can. Oh, but it's
concentration equals to moles divided by volume.
Then mole equals to products. So I have 1 mole, the mole of the hydrogen.
So it's 1:1.
Yeah, is it?
Yeah.
Okay.
So you see the combination, it's always a balanced equation. Then after that, then the mole question. But of course, I think in your O-level exams, you will see more of
the mole or
no, if you go for exam, right, there is a high chance that they will give you the equation straight away.
Oh, so they want us find the mole.
So if you have a question where they ask you to balance the chemical equation and then find the mole, right?
Yeah.
Then there will be lesser mole questions. If they give you the chemical equation straight away, right, then you will have to expect more questions, calculation from behind. Then because it's an exam, you have to take note whether there's limiting reagent or not. That's one. Then second thing is you may run into concentration questions, which is what we have at this section.
Okay.
Yeah. So if they give you they ask you to write a chemical equation, this one is a giveaway mark usually.
Okay.
Yeah. But if you don't know how to write, then giveaway also don't have one.
That's true. So
But you pray that there is the equation given to you, because then, right, even if you don't know how to write the chemical equation, then you will still be able to do the later parts. If you don't have the chemical equation, they never give you, right? Then behind also don't need to do it.
Okay. Hydrochloric, chloride, hydrogen, right?
Okay.
So this one is I find the mole of the hydrochloric acid.
It is very much torture right now because I don't have to say anything and you'll be doing all the work.
Oh, okay. Determine the number of tablets should be taken.
Which tablet? Oh, haven't finished.
So what do they mean?
Okay, so you have 150 cubic centimeter of this thing, then you 喝下肚子了。Yeah, no, this thing is in your stomach. Then after that, right, then you calculate the number of moles of acid you have in your stomach. Then you have to decide how many grams of tablets you're going to consume. So then by the balance equation, you will know that by mole ratio, you know how many moles of MgO you need to consume.
Okay, so I need 0.3 moles of the thing.
1 mole of MgO will react with 2 moles of HCl.
Oh no, so it's divide by 2.
Yeah. So then after that, you know the number of moles already, right? Then you can calculate the number of grams of MgO that you need.
Okay.
Then you have the total number of grams already, right? Of MgO. Then you know that every MgO tablet is 3 grams. Then you just
so I
divide
know
and
how
find out.
Okay.
Yeah.
Okay, now I have mole. Now I can how is it? I need the MR. Was it the other way?
Number of moles is mass over MR. Yeah. 哇，你要吃多少粒呀？
Very acidic, I guess.
Well, usually if you have stomach issues, you only take 2 tablets.
Oh yeah, 2 tablets.
Really, 2 tablets.
Unless I do only.
So this is accurate.
Yeah.
Simple.
Right, it's the what? Mole to MR. Oh, I need to find MR first. Oh shit, hydroxide. Hydroxide is just. Is it? Calculate the volume of the solution.
28.
So I using this one to find the volume. If it's this. So I divide.
Gram per dm cube equals to mass over volume. And this is.
Oh, so I just okay. Is it? I don't know. And that's kind of that. Okay.
Yours is in dm cube.
Oh, wait. So dm cube, right? Change it to
gram per cm cube. Your this thing right down here, or
it's not cm cube, it's dm
it's
cube.
dm cube because of this one. Then you just take 0.5 times 56, right? This is dm cube.
Okay.
This is titration. Combined science maybe not so much.
Titration. What is that?
Yeah, so they call it volumetric analysis. Sometimes you see titration. So what they do is you have a burette. And then you have a conical flask. Then after that, then usually they will have some volume of acid or base inside the conical flask, and you are supposed to pour in the opposite, right? Which is either if you have acid in the flask, you will pour in alkalis from the burette. You pour until the neutralization takes place, and then you will just take down the numbers. So how you know that a neutralization has taken place, right, is you have to use something called an indicator.
Oh, like
your phenolphthalein lah, methyl orange, methyl green, whatever you call it, spring methyl orange, that kind of thing. So you use the indicator. Then when the indicator change color, then that means the endpoint is reached. That means neutralization takes place completely. So you take down volume of this, you take down volume in the burette that you pour in. So
this process is called the
titration.
Titration.
Yeah, it's used in preparation of salt.
Because of the neutralization.
Yeah.
Oh, okay.
Titration is used to prepare soluble salts. The sparse salts are especially.
Okay.
Yeah, if it's unfamiliar to you, then we have to do something about it soon. So in questions for volumetric analysis, they will give you the chemical names. Then after that, you would need to first get a balance equation.
Oh yeah. Balance equation.
You balance the equation first. Then there are two methods to do this question.
But it doesn't have a result. No, I can make the result.
You can write down the result I taught you.
Hydroxide H. No, it's OH. That does nothing. It doesn't look right. So is it hydrogen first? Yes, right.
H plus.
Oh yeah. It's oxygen. That's okay. Is it? This last H2O.
Salt plus water. Yeah, not balanced yet.
Oh, okay. Oh yeah, not balanced. Like this.
Yeah, then. Okay,
Oh,
so you can do your usual method. Okay, so the usual method will be like this. First, you find your number of moles of sulfuric acid.
Oh, because they give us the things, right?
Then after that, you mole ratio to find the number of moles of sodium hydroxide. Then after that, you would use your mole over volume to find the concentration for sodium hydroxide.
Okay.
That's the normal method.
Oh, it's bad. So mole is concentration. Is it? Oh, right. Yeah, that's annoying.
So then that means this is 0.0275. This will be
times 2. So now I have more. I can get all. Then they give us.
There's another method. So the other method is like this. The moles times volume. So you can do acid or base, it doesn't matter. Over moles times volume equals to mole ratio of acid over mole ratio of alkali. So what happens is, right, no, let's not use mole. Use concentration. Mole per dm cube. So concentration. So you can use this formula to do this. So what can be done, right, is if I use acid on top, right?
Yeah.
So concentration of acid is 1 times volume 27.5 over 2. This one is you don't know, right?
Yeah.
So concentration times 25 equals to acid on top, the other one below. So 25 times concentration equals to 2 times 27.5.
Oh, why is it 1/2?
Here is 1. Acid is 1.
Oh, so it's the mole ratio.
If I got the formula correct, it should turn out the same way. So 2 times 27.5 divide by 25.
Yeah, it's the same.
So the formula can be reversed. So you use alkali on top, then your concentration value will be on top.
It doesn't matter lah. But
it doesn't matter lah. If you put acid on top, then the right side, the number of moles must be acid on top also.
Okay.
Yeah. Then I don't know whether your school teacher taught you this. Certain schools teach, certain schools don't. So, but I'm just providing you with two methods. The usual one will be the first one that I see most schools, they are using that.
Oh, the find the mole one, right?
The one that we did earlier, this one.
Okay.
Not the formula one. The formula one, not all schools will teach. So other applications of titration, you get 27 and 28. Okay, 27 and 28 is a bit complicated. Okay. Maybe you want to read the question and then tell me what you understand from the question.
Okay.
Yeah, it's a bit intimidating.
You
know what's going on or not?
Kind of, like it's a bit confusing.
It is a bit complicated.
Yeah.
Yeah, and it's very much more complicated than the questions before this, right?
Yeah.
Okay, so story goes, that means I have a solution here, which is called FeSO4 dot XH2O. Dot XH2O, that one is called the water of crystallization. So you say in 1 dm cube of this solution, there is 30.0 grams of that iron sulfate. Okay. Then they give it a name called solution Y. Then after that, then they say the solution Y will react with potassium manganate 7 here. And potassium manganate 7, there are 27 cubic centimeter of it, and the concentration is 0.02 moles per dm cube. So my question number 1 here is, can you find the number of moles here?
Yes.
Okay, so in a while we'll leave you to do this. Then after that, the story continue and tell you that 5 moles of iron sulfate reacts with 1 mole of KMnO4. Okay.
Okay.
Then in the titration, we need 25 cubic centimeter of Y. So for now, I think we only have this much. So we'll let you find the number of moles of KMnO4 first. So number of moles of KMnO4 is this, is correct. So over here we have 0.00054. So iron sulfate will be that times 5. Is this correct?
Yeah.
So they say in the titration, we use 25 cubic centimeter of Y. So that means in 25 cubic centimeter of Y, there is 0.0027 mole, right?
Yeah.
So can you calculate the concentration of Y? Okay, so this is 0.108 mole per dm cube, right?
Yeah.
So then in 1 dm cube, they say there's 30 grams. And you now know that this is 0.108 moles inside here, the top part, the solution Y. So can I find the MR from this information? Number of moles is equals to mass over MR. So this is 0.108. Mass is 30. Somewhere there, you know, MR is 277.789. Okay, so back to this, you know, the MR is equals to 277.77. Like that, right?
Yeah.
So iron is 56, sulfur is 32, then oxygen is 16 plus water is 18 times X. Then you solve for X. Yeah, so that's how you get the X under.
Okay.
This one is difficult. You have the equation like that, then X is to Y. Then they say 25 of the, and then you get this. So what you do is you find the number of moles of this and find the number of moles of this.
Oh, then just compare, right?
Yeah.
Okay.
Then you just ratio like that, right? Once you get the answer, then you find the answer is to answer, then you find the simplest ratio. Then that is XY.
Okay. Oh, that's big. Yeah, why is it so big?
就这样大。
It's very big.
That'll be what? 0.0400 divided by 1000 times 25. Very small. Why got so big?
Then how come mine so big? Oh, wait. No, it's a lot smaller. Oh, but it's still the same answer. Yeah.
Yeah.
Okay.